thing I want to talk about is how to think lexicographically. And if you need to think lexicographically, you need to understand what it means. So, basic definition of lexicographically: having a system where letters or numbers or sometimes a character corresponds to a numerical value. So, example, let's say that we have like a 7, and that 7, like just a character on your keyboard, if you type in a 7, that corresponds to some number, let's say 120. And then we can put in A, and if we type in A corresponds to 152. Think lexicographically means that you assign values to characters. So to think lexicographically, we need to come up with a basic a code of how Java interprets characters numerically. And I'm just going to make a list. This is increasing value as you go down. I like to think of it that way. The first characters would be numbers. Then we'd have our uppercase letters. And then we'd have lowercase letters. So what this means is that the number, if you put in a number, lexicographically, that numerical value that corresponds to the number is going to be smaller than the number that would correspond to your lowercase value, your lowercase character numerically. And so these, of course, would correspond to a number range like X through Y, and like Z through like B through C or whatever. And those would be our values that correspond to it. So the first thing I want to do is talk about the compareTo method. So .compareTo, you will use this method if you're trying to take strings, which of course is just characters, and order those strings alphabetically or numerically. So one of the most common uses of the compareTo method is to have some variable word1 .compareTo, and then you'd put in whatever you want to be compared to. And of course, these are variables. If these were strings, I would have put quotation marks around them. That's how we can tell that they're variables. So if I were to initialize, or I would have had to have done this earlier, but I would have the variable string word1 equals whatever, and string word2 equals whatever. And this is just, I'm not going to actually, I mean, I wrote the semicolon here, but I'm not going to do that. So this isn't something that you could just type into Java and it would work. So I'm just writing this. But let's say that string of word1 equals student, and word2 equals teacher. Now, if we were to call upon this method right here, so those are my variables, but that's the compareTo method. If we were to call that, what it would do, inside Java's brain, you could say it would take student, and it would look at student, this is a lowercase, and then it would look at teacher. And it would say, is it greater than, less than, or equal to? So, if we look at this, I really didn't tell you enough information, but you can kind of assume that numbers would range from 0 to 9, that this would be A to Z, A through Z, and this would be lowercase a through lowercase c, Z, not C, Z. And this would mean that lowercase z would be the largest numerical value lexicographically, which would mean that T would therefore be the larger value compared to S. And this is because T is closer to the N, therefore has a higher value. We can think of this as a number line, I guess. So we could have like 100 over here and 0 here, and teacher is closer to that 100 than student, not by much, but because Z is over here and A is over here. And so, well, that says teacher and that says student. We know that teacher has more weight. It's a heavier number. It's closer to Z. I'm sorry, letter. It's closer to Z, and therefore it weighs more. We can think of it in terms of weight, if that helps. And therefore, student is less than teacher because student comes before teacher. And we can even think about this more deeper thinking if we think of actually what Java is doing, which is like essentially you could think of it as subtracting these two strings, but you can't really subtract them. But again, it's assigning numerical values. So if we subtracted student minus teacher, we would get a negative number, which I'm pretty sure would be -1, just because this has a lesser value than the teacher. Student is less than teacher because teacher has a greater number. Again, why? Because it goes through A to Z. T comes after S, and so this would have a greater value. So it's going to be less than, which means it would produce a negative number, and from this, Java would probably return -1, which is a difference. And again, if we had like 79 here minus 80, we would get -1. The only way that we could get a positive number is if word 1 was greater than word 2, and then we'd have something like 81 minus 80 yields +1. So let's do another example. Let's say that word 1, I'm not going to make it string or whatever, but just quickly, word 1 equals test, and word 2 equals quiz. Okay, and now let's say we call word 1 dot compare to word 2. Now in this case, what Java is going to do here is look at test versus quiz. And essentially, test is our base mark. We're not changing test. We're trying to figure out how quiz is in relation to test. And this is because the variable, the string, whatever you put first, it's comparing this number to that number that you put first. It's not comparing it the other way around. So this kind of stays, and then we change our whatever it's going to be, equals, less than, or greater to, according to what the word 1 was, or what our first variable string was. So in this case, we see that T comes after Q in the alphabet. So if we subtracted, so again, I'll draw a number line. And we have A through Z. Again, this is lowercase, so that's why they're lowercase. And we have 0 and 100, because again, A is always less than Z. And if we have T here, so test, quiz here, then test is going to be greater than quiz. Therefore, greater. And this would return a positive value, because if we subtracted test minus quiz, that's the same as having maybe 81 minus 80, which yields a positive number. Positive number. So let's do another example.